Good day, students. Welcome to mathgotserved.com. In this clip, we're going to be going over Volume 2, Part 3 of our ACT review. We're going to be looking at problems 11 to 15. If you'd like to gain access to all the latest information for the ACT, you can visit the official website at actstudent.org. All right, let's take a look at question number 11. Question number 11 is assessing your ability to accurately apply the order of operations. Please excuse my dear Aunt Sally. Okay. Question 11 read, Charles defined a new operation, spade, diamond on pairs of ordered pairs of integers as follows. So the ordered pair AB, diamond CD is equal to AC plus BD over AB minus CD. So the question is, what is the value of the ordered pair 2, 1, diamond 3, 4? Okay. All right, so let's see what we have here. We have two ordered pairs 2, 1 related by this definition that Charles came up with in his definition. Diamond is relating these two points, 3, 4. Okay. So the assignment of the values of the coordinates, the first coordinate is assigned AB, and the second coordinate is assigned CD. Okay, if we apply the formula, the operation that Charles created here, it just involves multiplying AC, which is A is 2, 3 is C, so it's 2 times 3. That's AC plus BD. BD is 1 times 4. And then we're going to divide that by AB, which is 2 times 1, minus CD, which is 3 times 4. Okay, so let me just put the letters on top. You have AC plus BD. That's the numerator of his operation. And the denominator is AB minus CD. So we just substituted what AB and CD are. Okay. Now, to simplify this to get a numerical value, we're going to have to apply the order of operations. Okay, so you remember what your order of operations are. So please excuse my dear Aunt Sally. Okay, so what does it mean? P says you carry out the operation in the parenthesis first. Okay, and then the E, if you have any term with exponents, you move on to simplify that, the exponent term next, and then multiply and divide are done at the same time, but you do it from left to right. Okay, whichever one shows up from the left side is the operation that you carry out first. Okay, MD they're done the same time from left to right. So M stands for multiply, or divide from left to right, whichever one comes first. All right, the same principle applies to AS in PEMDAS. Addition and subtraction are done at the same time, but whichever one shows up first from the left, that's the one that you do first. Okay, so AS means add or subtract. Add or subtract from left to right. All right, so we're going to apply the order of operations in simplifying this expression that we derived from the application of the operation that Charles defined. Okay. All right, so what are we doing here? If you take a look at what we have here, we have the numerator and the denominator. We can view it as though we have the numerator grouped together and the denominator grouped together because of this division bar separates them. So basically we have to do the numerator and denominator separately first because they're in parentheses. Okay, so if we look at the numerator, parentheses, we have product and addition. So what do we do first? Do we add the numbers or multiply? Multiply and divide goes together, so you multiply first. In the numerator you have 2 times 3, which is 6, plus, and then 1 times 4, which is 4. All right, that divided by, and then we're gonna do, oh snap, we're gonna do the denominator next. So if we want to do the denominator next, we're going to follow the same order. We're going to multiply before we subtract, okay? So 2 times 1 is 2, minus 3 times 4 is 12, okay? All right, so what are we doing now? Are we dividing first, or are we going to add and subtract first? Well, we have the addition in the parentheses and the subtraction in the parentheses. So following the order of operations, we will do the operations in the parentheses first, okay? So 6 plus 4 is 10, divided by 2 minus 12 is negative 10. And then you can divide the top and bottom by 10, and you get 1 over negative 1. And your final answer is negative 1. All right? So the answer to question number 11 is option letter B. All right, so let's just put divide by 10 here. That's how we reduced 10 over negative 10 into this, and there goes our final answer right there. Alrighty, let's take a look at question 12. Question 12 is assessing our ability to accurately apply the triangle angle sum theorem and use that to find the exterior angle of a triangle. Okay, so the question reads 12. In the figure below, angle BAC measures 30 degrees, angle ABC measures 110, and points BCD are collinear. Question, what is the measure of angle ACD? So let's label what we have. Angle BAC is 30 degrees. Angle ABC is 110 degrees. Angle ACD is what we're looking for, so let's call that Y. And then let's call angle BCA X. Okay? All right, so how are we going to go about solving this problem? Well, this is a strategy that we're going to employ here. There are two ways to do this, but we're going to use the easier way, which involves finding X first and then using X to find Y. There's another way that this can be done. Okay, so let's recall what the relevant theorems that we're going to be using and postulates for this problem are. So you want to remember the triangle angle sum theorem. Okay, triangle angle sum theorem. What does the triangle angle sum theorem say? Well, the triangle angle theorem says that the sum of angles in a triangle equals 180 degrees. They're basically, they form 180 degrees, okay? And then you also have to remember your linear pair postulate, all right? The linear pair postulate says if a linear pair forms, if two angles, a pair of angles form a straight line, then they're supplementary, okay? The sum of angles on a straight line is 180 degrees. All right, so we're going to use the triangle angle sum theorem to find X first. Okay, so part one, we want to find X, and then we'll use that answer to find Y. Okay, so to find X, using the triangle angle sum theorem, we know that 30 plus 110 plus X form a sum of angles in the triangle, which is 180. Okay, so if we add 30 plus 110, that gives us 140 plus X equals 180. And then we can subtract 140 from both sides of the equation to give us what angle X is. So angle X is equal to 40 degrees. All right, now the second part is we want to find Y. So to find Y, we're going to use the linear pair postulate. Okay, angle X and Y are a linear pair. So since angle X and Y are a linear pair, it follows that X plus Y is equal to 180 based on the linear pair postulate. Okay, so we will substitute the value of X, which is 40, into this equation. So 40 plus Y equals 180. if we subtract 40 from both sides of the equation, that will give us the value that we are looking for. Y is equal to 140 degrees. Okay? All right, so that's the answer to question number 12 is option G. All right, there's another way to do this. You just realize it involves knowing that the exterior angle of a triangle is equal to the sum of the interior opposite angles. All right, so if you knew that, you would have just simply been able to tell that these two angles right here are the interior opposite angles of this exterior angle y. So you can just simply find y by adding these two opposite interior angles to get y. Okay? And that makes sense because y is a supplement to this angle right here. It adds up to 180 with x. And these two add up with this to form 180. So it automatically follows that these two, 30 plus 110, must be equal to y. All right, so that's just another way of doing question number 12. All right, let's take a look at question number 13. All right, so question number 13 is assessing ability to either make use of the Pythagorean theorem or special triangles. Okay, we're going to be making use of both approaches in solving this problem. Question 13 reads, in the isosceles right triangle below, AB is 10 feet. What is the length in feet of segment AC? Okay, all right, so the first method we're going to employ in solving this problem, method 1, is the Pythagorean theorem. All right, that is a must know for the ACT. Alrighty, so the Pythagorean theorem is as follows. So let's say we have a right triangle. Okay, in this particular case, let's label it. This is ABC. AB is 10, and we're looking for the AC, which is x. So since this triangle is isosceles, what does that mean? If it's isosceles, that basically means the two legs are congruent, right? So this leg AB is congruent to this leg CB. So this is also 10. Alrighty? Okay. What is the Pythagorean theorem? The Pythagorean theorem is as follows. It basically tells you that the sum of the square of the legs, a square plus b square, is equal to the square of the hypotenuse. Okay, so in this problem, the legs are a and b. It doesn't matter how you label them, but the hypotenuse is always c. So when we substitute these values into the Pythagorean theorem, we have 10 square plus 10 square equals c, which is x squared. All right, let's simplify this. We have 100 plus 100 equals x squared. 100 plus 100 is 200. 200 equals x squared. To get x by itself, we're going to proceed to take the square root of both sides, since square root is the inverse of square. Okay, so the square root gets rid of the square. So we have x equals the square root of 200. Okay, all right, so what's the square root of 200? If you are familiar with your perfect squares, you can easily tell that this is 2 times 100, and that reduces to 10 root 2, and the answer is E. Okay, if you're not familiar with doing your perfect squares mentally, you can always break it down. Let's do that. So you take out 2 into 200 is 100. I'm breaking it down into the prime factor decomposition. All right, 2 goes into 100 50 times. 2 goes into 50 25, and then 25, 5 goes into 25 5 times. All right, so since this is a square root, every pair that repeats, every factor that repeats, or every pair is a square, so it comes out as its root. Okay, so 2 times 2 is a square. The square root of 2 times 2 is 2, so these come out as 2. And then we have another factor that repeats here, or a pair. 5 times 5 is 25. The square root of 25 is 5. So this number 2 doesn't have another factor, identical factor, so it's not a square. So it stays behind. Okay, so the simplified form of root 200 is these two numbers that came out. 2 times 5 is 10 root what's left behind 2. Alrighty, so we can clearly see that the answer is option letter D. Alright, let's use another method. Method 2 is faster, but you just need to know what your special triangles are, and you need to know how to apply them. Okay? Alright, so your special triangles. What are your special triangles? Let's review that real quick. Your special triangles, there are two of them. You have the 45, let's write that again. 45, 45, 90 special triangle. In this case, the ratio of the sides are 1 to 1 to root 2. You also have the 30, 45, 60 special triangle. Sorry, it's not 30, 45, 60. It's 30, 60, 90. That doesn't add up. All right, so 30, 60, 90 special triangle. 30, 60, 90. Sorry about that. So for the 30, 60, 90 triangle, the sides are in proportion. All 30, 60, 90 triangles, its sides are in proportion 1, root 3, and 2. Okay? So the one we're going to be using for this particular problem is the first one. You got to remember that all isosceles right triangles are of the form 45, 45, 90. Okay? Because this is 90 degrees right here. And since the two legs are congruent, that means the angles opposite them are congruent also. Okay? So if you take out 90 from 180, you're left with 90. You split that in two evenly. This would be 45, and this would be 45. So we have a special triangle. Voila. Okay? All right, so let's set it up. Using our special triangles, we have the sides are in the ratio 1 to root 2. So the legs are 1 and 1. So you have, put it here, we can have 10 to 10. Those are the legs, so 10 to 10 to x. That's what we're looking for. Alrighty, so we can simply use this to set up a proportion. Okay, because basically what we have is two similar triangles, and if you have two similar triangles, corresponding sides in proportion. Okay, so this triangle right here is similar to the standard 45, 45, 90 triangle. So this is basically the template. So it's in proportion is similar to this 1, 1 root 2. All right, so how do you set up ratios? How do you set up a proportion of equivalent ratios using similar triangles? You just set up a ratio with corresponding sides. Okay, so 1 over, what sides correspond to this one in the big triangle? 10, right? Equals, so this side is the known, and then the next side will have the unknown. Okay, equals root 2, the hypotenuse of the standard triangle, divided by what we're looking for here, which is x. All right, so there goes your proportion set up right there. All right, so now we have a proportion that we can just simply solve algebraically. And if we want to solve this proportion, we just simply cross multiply. Okay, so when we cross multiply, we have x equals 10 root 2. And there goes our final answer for question 13, which harmonizes with what we got earlier when we applied the Pythagorean theorem. All right, so question number 14 is assessing ability to carry out probability calculations using percentages. Question 14 reads, in a bag of 400 jelly beans, 25% of the jelly beans are red in color. If you randomly pick a jelly bean from the bag, what is the probability that the jelly bean picked is not one of the red jelly beans? Okay, all right, so what's the formula for probability of an event? Let's go over that first. So formula for probability, the probability of an event, let's call it P of E, is the desired outcome divided by the total possible outcomes. All right. All right. So in this particular case, we're looking for the probability that a selection will not be a red jelly bean. It's a red jelly bean. Okay. So if there are two possible outcomes for an experiment and the probability of one is x, then the probability of the other is simply going to be 1 minus x. Okay, so we find out the probability that the selection is a jelly bean and we subtract it from 1, we automatically get the probability that the event is not a jelly bean, because when we add two probabilities we get 1. Okay, all right, so that's one way of doing it. So let's start by figuring out what's the probability that you actually pick a red jelly bean. If we have, if 25% are jelly bean, then guess what? The probability, 25% are red jelly bean. Then the probability that you pick a red jelly bean is going to be 25% also. All right, then the probability that you pick a red jelly bean, let's call that P of red, is going to be 25% also in percentage form. How's that possible? Well, if you do the calculations, 25% of 400 is 100, and if you divide 100 by 400, you end up with 25%. Okay, so 25% can be written as a decimal, 0.25, or it can also be written as a fraction, 1 over 4. Okay, so if I want to write my probability in decimal form is 0.25 and as a fraction is 1/4. Now using these two values, I can easily calculate the probability that the outcome will not be red. All right, so the probability that it will not be red is simply going to be, since those are the only two outcomes we're looking at here, is simply going to be 1 minus 0.25, or you can say 1 minus 1/4. They're both the same thing. Okay, so 1 minus 0.25 is 0.75, and 1 minus 1/4 is 4/4 minus 1/4, which is 3/4. Okay, so that's one way of doing it. Another way of doing it is just thinking about what is the percentage that is not red. If 25% are red, then what? Then 75% of the jelly bean are not red. All right, so since 75% are not red, that's a percentage of the whole, then the probability that the selection will not be red is simply going to be 75%, because 75% of the number of jelly beans is 300, and if you divide that by 400, you're going to have 75% again. So it's just 300 over 400, right? Which is the same thing as the percentage that we had before, 75%. And 75% is the same thing as 0.75, and it's the same thing as 3 over 4. Okay, all these three mean exactly the same thing. So since the answer format that is desired here is a fractional format, we can clearly see that the answer that we desire is 3 over 4. That's the probability that the selection will not be a red jelly bean. All right, let's take a look at question number 15. Question number 15 is assessing your ability to carry out calculations involving operations on polynomials. Okay, can you add, subtract, multiply, divide polynomials? That's what we're looking at in this particular problem. Question 15 reads, what polynomial must be added to x squared minus 2x plus 6 so that the sum is 3x squared plus 7x? All right, so what we're going to be doing is setting up a polynomial equation involving an unknown polynomial and isolating what that unknown polynomial is. All right, so to set up an equation, we have to declare what our unknown is. Our unknown is a polynomial. It says what polynomial? So let's declare that unknown polynomial as p of x. Okay, so let the unknown polynomial be p of x. All right, so it says what polynomial must be added, so the operation is added to this polynomial so that the sum is this. Okay, so we're adding two polynomials, p of x, which is the unknown, we're adding it to this, and this is the answer that we're getting. Okay, so let's set up an equation using this information that we have. Okay, so polynomial p of x, the unknown, is added to x squared minus 2x plus 6, and the result is 3x squared plus 7x. So how do we get p of x isolated? We're just following basic algebraic procedures, right? We just subtract this polynomial from both sides of the equation. So you subtract x squared minus 2x plus 6 from both sides of the equation. So x squared minus 2x plus 6. Now this is extremely important. Note that when you have a minus in front of a parenthesis, do not forget to distribute. Okay? Let's write that down on the side here. So note, when you have a minus, when you have a negative sign in front of a parenthesis, do not forget to distribute. Okay? Do not forget to distribute. This is where most students will mess this problem up, is forgetting to distribute that negative sign across every term here. Okay, so number one, when you're subtracting polynomials, you have to use the parentheses to group them, and then the minus on the outside has to be distributed across. Okay, all right, so let me show you what I'm talking about. P of x is going to be, now these two are opposite, so they add up to 0, equal the difference between these two. So we have 3x squared plus 7x. All right, and then we have negative x squared minus 2x plus 6. Now take a look at this for a second. Is that correct? Does that agree with what I mentioned here about not forgetting to distribute? The answer is no, this is wrong, okay? So if you distribute this minus, this is the mistake most students make. They just drop the parentheses. If you distribute this minus, this term becomes negative. This negative 2x, guess what, becomes positive. It becomes positive, and so this becomes positive, and then the last sign there becomes negative, okay? So it's very important, don't forget to distribute the sign. So this minus goes to 1, 2, and 3. Alrighty? Okay, so let's simplify now that we've corrected the whole thing. So 3x squared minus x is 2x squared. 7x plus 2x is 9x minus 6. The answer to question number 15 is letter D. Thanks so much for taking the time to watch this presentation. I really appreciate it. If you found the contents of this tutorial helpful in your preparation for the upcoming ACT, do give us a like. We do appreciate your positive feedback. If you have any questions or comments about what we covered in this presentation, or any questions concerning the ACT in general, just place your questions in the comment section below, and we'll try our best to respond. Don't forget to subscribe to our channel. We upload videos to our page on a weekly basis, so do subscribe so you can get notification of future updates. For more support resources to get you ready to pass the ACT, including free practice tests, visit our website at mathgotserved.com. Just click on the ACT link and you will gain access to a bunch of valuable resources. Thanks again for watching and have a wonderful day. Goodbye.